We're going to start today's discussion with a little bit of review over bonding. So, once again, ionic bonding. Ionic bonding is a type of bond between what type of elements? A metal and a nonmetal that form what? Metals and nonmetals form cations and anions by gaining and losing electrons. And when we have a compound that is ionically bonded, we've referred to it as a couple of things. One is that it is a salt. When we talk about ionic bonding, we talk about substances being formed, being called salts. Salts, and remember that a formula unit is the name given to something that is ionically bonded. A formula unit. Covalent bonding is a type of bond between what? Non-metals. Two or more non-metals. We'll talk about, I think it's next week when we discuss polyatomic ions, because those are covalently bonded. And, sometimes there are 5 different atoms that are covalently bonded together. Covalent bonds result in compounds that we call molecules. Okay? So, going back here, a molecule is something that is covalently bonded. A formula unit is something that is ionically bonded. Now here's the new stuff, molecular geometry. And I would like for you to get that slide right there in your notes. I'm going to pass out a packet that you are going to need to do molecular geometry. So copy this down in your notes. Now you can see with this perspective drawing that there are a couple of different things. This solid line here and this solid line here are what they are calling a normal bond. They have 2 different ways. The one I like to use is just these hashes like this. Sometimes I guess I use it like that. Those hashes and this wedge bond right here. Now, what do those mean? Let me get those off of here. This wedge bond right here. The things that we are trying to do here is we are trying to signify something that is 3-dimensional on a 2-dimension piece of paper, which is not easy to do. So, how we do it is that wedge bond right there signifies that that is coming out of the board. This dash bond, the dash bond or the hash bond, let me do it a different color. This dash bond, and I just use that one there. Just a bunch of dashes signify that it is going back to the board. Now, if you can't see that, let's look at this little model that I have in my hand. Okay? this model that I have in my hand, what I am doing is the red bonds, the A and the A, right there, I'm going to put on the same plane as this cardboard. So here are my two red bonds right here. They are on that plane. Now, can you see that one is in front of the plane and one is behind the plane? Can you see that? So, when I put it on the plane, I line up these three right on that plane. One is in front, one is behind. The wedge is the one that's in front. The dashes are the ones that go behind. That is all that that perspective drawing is signaling right there. All right? So, the perspective drawing allows us to show the geometry, the shape that those bonds are occurring, even though we have a two-dimensional setting. Now these elements right here, are ones that you need to memorize. So write those down and we will memorize these by shape, formula, and name. The very first molecule over here is methane, CH4. We talked about that yesterday, didn't we? Didn't we even draw the Lewis dot structure for methane yesterday? I think we did ammonia too, didn't we? Okay. I thought methane was the first one we did. Oh, it was chlorine, wasn't it? It was carbon with chlorine, carbon tetrachloride. Okay. Now methane, okay? Just a carbon surrounded by 4 hydrogens that are single covalent bonds. Okay, so you will end up memorizing the shape of this also. But whenever you see CH4, it is methane. NH3 is ammonia. It is ammonia. And notice that this wedge bond here is not actually a bond. That's just an unshared pair of electrons. Okay? They're saying that these unshared pair are coming out of the board. This hydrogen's going back into the board. Okay? Ammonia. We're all familiar with water. Okay? We're all familiar with water. Notice the 2 unshared pair of electrons here. So those 4 electrons right here are all water's electrons. Here's a covalent bond. Here is a covalent bond. But you need to memorize the common names because these are common names for all of these. Really, based on our nomenclature that we'll do next, that's the next unit we cover. But based on our nomenclature, you know, this would be, let's see, carbon tetrahydride. This would be nitrogen trihydride, and this would be dihydrogen monoxide. Now, obviously, we don't call any one of those by those names. We use the simple, okay, these names, methane, ammonia, and water. Common names. I told you we would talk about Vesper. I told you we would talk about Vesper. And this is an important slide too, so you need to probably copy this exactly. First of all, I call this Vesper. Vesper. And I know that it shouldn't sound like it's Vesper, but it is Vesper. That's what I call it. What it is its abbreviation. Valence, shell, electron, pair, repulsion. the valence shell electron pair repulsion theory. And that's exactly what it is, that these valence shell electrons are repelling each other. How much they repel each other depends on what it is. Okay? Obviously, triple bonds repel more than double bonds that repel more than single bonds. Okay? Unshared pair has a different repulsion too. Okay? So, the valence shell electron pair repulsion theory. When we are doing the VSEPR theory, you will talk about the AX method. The AX method. The A represents the central atom. The X represents the number of bonds between the central atoms and the outside atoms. It can be multiple, meaning single or double. We still count that as 1X. You'll understand that here in a second. It's how many covalent bonds there are. And finally, the E represents the lone pair of electrons. The E represents the lone pair of electrons. Well, we did that yesterday, didn't we? Carbon tetrachloride. We came up with this exact Lewis structure. Look at that. Does it obey the octet rule? Absolutely. Now, what we need to do is we need to do the AX method on this. All right? So A represents the central atom. What is my central atom in this? Carbon is my central atom. What does X represent? Number of bonds. Well, how many covalent bonds do I have here? 1, 2, 3, 4. I have 4 covalent bonds here. E represents what? E represents what? Talk louder, I can't hear you. Lone pair of electrons. Now, this is where you'll get confused, because it means lone pair of electrons around the central atom. Okay? I have bundles of lone pair of electrons here, don't I? But none of them are around carbon, are they? So how many lone pairs are around carbon? 0. So by using the AX method, here is my AX. AX4E0. AX4E0. Now, what I want you to do, and I'm going to have to find this because I know I don't have it up yet. I'm going to have to find this, so give me a second here. First of all, take out that packet that I just gave you. This is the molecular geometry. You may want to highlight the ones that I have up here in red, because yours says that the ones in red need to be known. You might want to highlight those because you need to memorize these, because they are the most common of the shapes. So what I want you to do is just highlight the ones in red up there. They are the most common of the shapes that we will see. Notice also that there are two bents up there. Okay, just be aware of that. There are two bents up there. So be aware of two bents. Now, you could use this grouping right here. Okay, you could use these right here. Lone pair of electrons, bonding groups. All right, you could use those. So if we would, okay, bonding groups represents our X, right? Lone pair represents our E. So by reading this chart for the one we just had, where our X was 4, our E was 0, that would leave us with a tetrahedral shape. Now, this is one of the guys that you can use. I myself do not use this one. Okay? I myself do not use this one. I use, let me get these letters off of here. This. So find this page right here where it says molecule type, because right on the very first column it has AXE values, doesn't it? Go down until you find AX4E0. Have you found it? Now we know that we have tetrahedral, don't we? AX4, AX4E0. So as I come down, I don't have it on here yet. Let me get down here a little bit. Get down, get down, get down. Right here. AX4, even though you can't read it, I'm sure, you can look at your packet, tetrahedral. It even gives us some examples right here of tetrahedral ones. Now, what does this mean? Well, this tells us, number one, that this is the shape of that is tetrahedral. Number two, it's going to help us draw it. How is it going to help us draw it? Because now I'm going to go back up here and see all these. What these are lines, wedges, and dashes. Lines, wedges, and dashes. So now I find tetrahedral up here. Found it. Found it. Right here is tetrahedral. So, when I'm going to draw methane, I can see that my A is in the middle. I have a straight line to the first H. I have a straight line down here to the second H. I have a wedge here to this H, and I have a dash to that H. So do you see how I took the axe, I found the shape, and then I drew it using that very one you have there. I guess those should be chlorines because we were doing carbon tetrachloride, right? But nonetheless, you get my point. How to use the packet. Okay? How to use the packet. So when you do your test over bonding, you will have a packet available to you. Will it be your packet? I didn't say that. I didn't say it would be your packet, but you will have a packet. So I'm getting this stuff off of my screen here. And I'm going to go back to my pinpoint. So we know it's tetrahedral, and then we just drew that. So the main thing is here, to be able to tell me what the molecular geometry is, and then be able to draw it. We will do a lot of this next week. You will be doing a lab where you get to play with the little model kits. Okay? You get to play with the little models. Now let's do another one. I believe I showed you carbon dioxide yesterday too, didn't I? Okay? Carbon dioxide. We're going to ax him too. We're going to ax him too. So what is A in this situation? Carbon again, right? X represents what? Number of bonds. Okay? So I look here. Here is one bond. It's a double bond. But we just count it as one. That's one bond. Here's one bond, right? So, X is what? 2. How many? What does E stand for? Lone electrons. Unshared pair. How many do we have? 0. Don't tell me 4. Don't tell me 4. Why don't tell me 4? Because it's the central atom. It's a central atom. So, AX2E0. I want you to find this and tell me what shape we're dealing with here. We're dealing with linear? Wrong. Too many. There's too many there. Okay. We're dealing with linear. Correct? So now, go back to your packet and find linear. Now, there are 2 linears. Go to the very, very back page. There's a linear on that page, right? Find the linear on the very, very back page. Do you have a central atom with 5 things around it? Okay. Okay, it's the second to last page. Okay. Do you have an A with 3 E's and 2 X's? No. Okay, so that's not the linear we're looking for. Go back earlier in the packet. You're going to see the very first one, where an A with 2 X's. So how am I going to draw this? Just simply like that. We can put this all on the same plane. So you would just simply draw carbon with oxygens. Now, if it's me drawing them, I put that in. If it's me drawing this, because if I would draw it like this, what would you think? You would think those are single bonded, right? Are they single? No. So I'm drawing it with my lines, but I'm making the double bonds, not just the straight line. Not too tough, is it? Here's our other guy, ammonia. He got pneumonia. Okay? Ammonia. I look at this. Let's ax it. Let's ax it. A is what? Nitrogen. X is what? 3. I have 3 bonds. 1, 2, 3. What is E? 1. So I'm dealing with AX3E1. Can you find AX3E1? X3E1 trigonal pyramidal. And if you look at the examples, ammonia is one on there. So when I come back and I'm going to draw trigonal pyramidal, okay, find that. Find that. And I'm going to use my dashes. I'm going to use my dashes, and I'm going to use my wedges, and I'm going to use my regular lines. I'm going to draw this as N in the middle. There is my E, okay, which is an unshared pair, right? My X's are here. I have a wedge here. And I have dashes here. So I have now represented my perspective drawing for ammonia. Okay? My perspective drawing for ammonia. Now, just for practice, and what I want you to do, let me find something up here. I want you to draw the dot notation and do let's see. We'll make it a little bit difficult. We'll make it a little bit difficult for us. I'm going to go back to where this is blank, maybe. I don't have a blank one. So, we're going to do an example